Hi everyone. The topic for this video is recursive function in Python. We know what is function. A function is a collection of statements that called by a name and written once and executed n number of times whenever required. A function can call itself. That means within the definition of a function, the same function can be called. In that case, that is called recursive function. So a function defined in terms of itself or a function calls itself until a condition is met. So until a condition is met, this function is calling itself again and again. This is called recursive function. So recursive functions are derived from the problem solving strategy recursion. What is recursion? Recursion is a problem of or it's a process of dividing a problem into smaller subproblems and solving this subproblems in an iterative fashion or in the sequential fashion where the result of solution for one subproblem is passed as the input the next subproblem, and every subproblem passes the result to its next subproblem. So this is how the subproblems are solved, and finally if you are combining the results of all these subproblems, you will get the final solution for the problem. This is called recursion. Now, this recursion can be implemented in Python by using recursive function. So, a function will accept a parameter and it will process it, and after processing it, it will pass that result as a parameter to itself, and it will be calling itself, and again it will come with a new value and it will continue its iteration or it will continue its execution until a condition is met. This is called recursive function. Now, when you are dividing the problem into subproblems, there are two parts. One is base case. What is base case? Base case is actually the subproblem or the division of subproblem, the division of the problem into subproblems until there is no possibility for subdivision. That means you are reaching at the end of division, subdivision of the problems, and that is the end of that division, and there that is called as best case. Sorry, base case. So base case is actually the end of subdivision of the problems into subproblems. Once you reach that base case, there you will stop calling the recursive function. Next one is recursive case. Recursive cases keep on dividing the problem into subproblems. That is called recursive case. Now let us have a small example of this base case and recursive case. Let us consider an example of calculating the factorial of the given number. Let us consider calculating the factorial of 5. That is 5 factorial. How to calculate 5 factorial? 5 factorial is calculated as 5 into 4 into 3 into 2 into 1. Now, if you are noticing it clearly, this 5 factorial is 5 into 5 into 4 into 3 into 2 into 1. It is 5 into 4 into 3 into 2 into 1. What is 4 into 3 into 2 into 1? It is 4 factorial. So it's 5 into 4 factorial. Now if you divide that 4 factorial again into subproblems, it is nothing but 4 into 3 into 2 into 1. So what is that? 4 into 3 into 2 into 1. That is 3 factorial. So already 5 into 4. Now into 3 into 2 into 1 is 3 factorial. Now again this 3 factorial can be subdivided into 3 into 2 into 1. What is that? 3 into 2 into 1. That is 2 factorial. So 5 into 4 into 3 into 2 into 1. That is 2 factorial. Now this 2 factorial can be subdivided, and that is 2 into 1 factorial, or 2 into 1. That is nothing but 2 into 1 factorial. Now this 1 factorial cannot be subdivided because 1 factorial is 1. So that is the end of dividing this problem into subproblems, right? So there now you have a problem of or subproblems of 5 into 4 into 3 into 2 into 1, right? And what is the base case here? 1 factorial is the base case. Once your factorial calculation reaches value 1, right, at that time you cannot divide it further, and 1 factorial means once 1, there you can stop the calculation of the factorial, right. So that is called the base case. And dividing the problem into 5 into 4 factorial, 4 into 3 factorial, 3 into 2 factorial, 2 into 1 factorial is called recursive case. You are subdividing the problem recursively and you are solving it. So these are the examples of base case and recursive case. Now, how to implement this factorial calculation using recursive functions? Now let us come to generalization of this problem. Okay? If you take n factorial instead of 5, let us take general number n factorial. What is n factorial? As we discussed, if you are taking 5 factorial, it is 5 into 4 into 3 into 2 into 1. This is what actually 5 factorial is. Like that, if you take n, then n factorial is n into, then n minus 1 into, n minus 2 into, n minus 3 into, till 3 into 2 into 1. So from the current number, from the number n till all the consecutive natural numbers till 1 will be multiplied. That is what actually the factorial of n, right? Now if you are okay, cut short this problem. Okay, you can come to a final derivation that n into n minus 1 factorial. So everywhere you are calculating n into n minus 1 factorial. So for example, 5 factorial is 5 into 4 factorial. 5 factorial is 5 into 4 factorial. Like that, 4 factorial is 4 into 3 factorial. 3 factorial is 3 into 2 factorial. So n factorial is equal to n into n minus 1 factorial. So every time you can repeat this process of multiplying the values from n to 1 by multiplying the value of n by the value which is previous to n, that is n minus 1, and or otherwise n into n minus 1 factorial. So n into, then calculate the factorial of its previous number. So you repeat it until you are reaching the value 1. Once you reach 1, you can stop multiplying it, right. So there are now we are clear about the base case and recursive case. So dividing the problem into smaller subproblems until no subdivision is required is called as base case. So base case is the case where we stop dividing the problem into further subdivisions, and we are stopping the process of doing the calculations, right. Now how recursive functions are working. Okay, we have to have the demonstration on recursive functions working. Let us take the same example and write the recursive function. So the recursive functions are written like the normal functions. Okay, so it starts with the def keyword, and let me write a function that is accepting a number and calculating its factorial value. So let me name it as factorial, and since it is using recursive method, let us name it as factorial underscore recursive. And this factorial underscore recursive is going to accept a particular number as input, right. So let us say it's n. Okay, n is the number for which it is finding the factorial, and ends with the colon. Now what we are going to do is we are going to calculate the factorial of n. Now how can you calculate the factorial of n? There are two cases, as I said, base case and recursive case. What is the base case here? If the number is 1, if the value of n is 1, there it's a base case. You can stop processing it, and factorial of 1 is 1, so just return it, right. So if the value of factorial is 1, when you are reaching the value of 1, or when a value of n is reaching the value 1, then we can stop processing and return the factorial of 1 directly, that is 1, right. So 1 factorial is directly calculated, so it's 1. So if n equal to 1, this is the base case. And one important thing is, if you are missing the base case, this recursion will happen indefinitely. There should be an end for the recursion. Okay, there should be an end for the recursive calling of the function, and the end is denoted by the base case. Here the base case is reaching 1. Okay, reaching 1, or the value of that number n is reaching 1. That is what the base case here. So if n equal to 1, in that case, return the factorial value of n or 1, that is 1. Else the number is not equal to 1. In that case, now how can you calculate the value of factorial? As we discussed in the example, the factorial can be calculated as n into n minus 1 factorial. So if you are supplying 5, then 5 will be multiplied by factorial of 5 minus 1, right? So it will repeat. Okay, right. So now how are we doing? We are actually multiplying the current value of n by factorial of, factorial is calculated by factorial recursive function, right? So factorial recursive of n minus 1. So the factorial value of a given number is calculated by multiplying that number by factorial of the number minus 1. This is how we can generalize the problem. Finally, we generalize the problem like this. We are repeating the process of n into n minus 1 factorial until we are reaching the base case 1. Okay, until the value of n is reaching 1, right? Here we stop the process of multiplication or process of calculating the factorial. So now you see n into factorial calculation of n minus 1, or n into factorial underscore recursive of n minus 1. Return this value. In every iteration, you return this value n into factorial of n minus 1 or factorial underscore recursive of n minus 1. Okay, so how it will work? For example, if you are supplying 5 to this n, okay, let me assume that print factorial of 5 is, for example, then factorial underscore recursive of 5, right? Now what will happen? At the first time, factorial underscore recursive of 5 will be called and control will transfer to this definition, and n will be copied with 5. So n will be having the value 5. Now 5 equal to 1? No, 5 is not equal to 1. In that case, this if block will not be satisfying its condition. So it will come to else block. In else block, what we are going to return is n into, so n is now 5. So 5 into factorial of 5 minus 1, that is factorial of 4. So 5 into factorial of 4, or 5 into 4 factorial. Now with value of 4, this function will again call itself. So now the same definition will be called and n will be copied with 4. Now 4 is not equal to 1 and it will come to else spot. Now it will return n into, already this value has a 5 and multiplied by the factorial of 4. So 5 is already there, now 4 is there, right? So already 5 is there, so 5 into, now 4 into, okay, 4 into, and factorial of recursive of 4 minus 1, it is 3. So 5 into 4 into 3 factorial is calculated. Now again control will come to definition, and now n is 3, 3 is not equal to 1, so again it will come here. So 5 into 4 into, already 5 into 4 into is already calculated, that is 20 is already calculated. So 20 into, now again n, okay, so 20 into 3, okay, 20 into 3, it is 60 into, right, factorial recursive of n minus 1. So 3 minus 1, 2. So now it is 60 into factorial recursive of 3. So now 3 is passed as parameter. So now again definition is coming here, or definition is called, and with the value of 3. So 3 is not equal to 1. Again control will come here, right? Not 3, right, 2, right? Already 3 minus 2, actually 5 into 4 into 3 is already calculated, and now it is 2. So 5 into 4 into 3 into 2 into 2 minus 1 is 1. So factorial of recursive of 1 is passed. So 5 into 4 into 3 into 2 is actually 120. Now remaining is 1 factorial. So here n is separated with 1, and 1 equal to 1, yes, condition is satisfied. so it will return 1. So in that case, already 5 into 4 into 3 into 2 is calculated. Now that is 120 into 1, this 120 again, so it will return 120. Now let us hope that this code will work properly, and let us run the code, run module. Yes, let us give us file name, for example factorial.py. Okay, and let us save it. Yes. Yes. Now factorial of 5 is 120. Okay, factorial of 5 is 120. Now let us make this program little general. That means let it accept any value and find the factorial of itself. Right. So print. Sorry. For example, let me assume that the number is num. So num equal to int of input of enter the number, right? And it will accept the number from the user in the form of or the type of integer, and it will be assigned to the variable num. Now let me pass the value to this num. Let me pass the variable value num to this function call, right? Now num factorial of num again is right, and the value returned by this function, right? Now let us run the module again. Enter number, for example 6, it is 720. So 5 into 6 into 5 into 4 into 3 into 2 into 1 is 720, right? For example, let us run it one more time. Enter the number, for example 10, it is the value of 10 factorial. Okay, right? Now this working. Let us have one more example. For example, I want to calculate the sum of first 10 natural numbers. So let me write a code for this. So def, then sum of natural numbers. This is what actually the function name is. Now this function takes two parameters. One is the value of the current natural number. Okay, the value of the current natural number. So what is the value of current natural number? For example, it is let me assume that there's a variable for the current natural number. Let it be num. Okay, num is denoting the current natural number. And next one, every time this number is added with the previous sum of natural numbers, that means it is keep on adding the natural numbers from 1 till the current number, or the current number minus 1. So till the sum numbers are added and sum is maintaining that sum, and now the current number is going to be added with that sum. So the sum value should be passed. Okay, the sum value should be passed as the parameter. So this function takes two parameters. One is the number, current natural number, that is to be added, and next one is the previous value of the sum of natural numbers till added. Okay, and now how it is working is this current natural number. Okay, the current natural number is going to be added with the sum value, right? So sum, okay, how to add the current natural number with the sum is actually sum equal to num plus sum, or sum plus num. That means the current sum is added with current natural number, right? Current natural number. Now what do you want to do? You want to continue the process of giving the next natural number. You want to continue the process of giving or adding the next natural number with the current value of sum. So how can you do it? You call the same function again, sum natural of next natural number from the current natural number can be obtained by adding 1 to that. So num plus 1, then sum is already added. See, sum is already added, right? So this process will repeat. Okay, this process will repeat, and so every time return this sum natural of num plus 1 comma num, that means sum, that is every time it is returning the value of current natural number. That means by adding 1 with the previous natural number, you are getting the current natural number, and current value of sum, okay, current value of sum is actually passed, right? Now let me assume that I'm calling this function. Okay, I'm calling this function print, okay, sum of first 10 natural numbers is, and I'm calling the function sum natural of, I am passing the value of first natural number as its input. Okay, I am passing the value of first natural number as its input. So that is 1 is the first natural number, and current sum value is 0, because if you are going to use a variable for summation purpose, that means in future you are going to add some value with that variable, you should initialize that variable with 0, so it will not its current value or initial value will not affect the result or the value that is going to be okay, added with that sum. So now the sum is initialized to 0, right? But what is the problem here is this function will run indefinitely. Okay, this because actually we are not giving any condition or any base case where this operations to stop, right? Actually, it will call with 1 and 0, then it will come here and it will add sum and no sum and num, right? 0 plus 1, and it will increment the number by 1 and its next natural number as well as the current value of sum is passed. It's keep on repeating, right? So there is no end for this function. So what is the end for this function? The end for this function is, right, the end for this function is, if suppose if the value of this number is reaching 11, because I am saying that the sum of first 10 natural numbers. So when the current value of the current value of the natural number is reaching 11, that is the end of the process. So what is the base case here? If num equal to 11, that is what the base case here. In that case, what you can do is you can return the sum. That's all. Because when actually when the value of number 1 is reaching, when the value of number is reaching 11, at that point you can stop processing, because you are going to calculate only up to 10, right? You are calculating the sum of first 10 natural numbers. So once the current value of natural number is reaching the value 11, then you can stop. You return the current value of sum. Else, now what you can do is you can calculate this okay, sum of the current value of sum as well as the current natural number, and return or call that natural number or some natural function again with new natural number and current value of sum, right? Now let us check whether this function or whether this recursive function is going to work properly. Okay, right. Run module. Yeah. Sum of first 10 natural numbers is 55. So it's working properly. At the same time, let us make this function or this recursive function works for any natural number. Okay, up to any natural number. So let us take one value, for example n. N is denoting the end of the sum of that natural numbers. For example, first 10 n natural numbers, first n natural numbers. So integer of input of enter the value of n. Okay. Now once you are accepting the value of n, okay, once you are accepting the value of n, what you are going to do is, okay, what you are going to do is you have to write, or otherwise you can do one thing. Okay, so what you can do is you can make it actually now it's 11, up to 11. Okay, so this function will work for first 10 natural numbers. Okay, it will work up to first 10 natural numbers. Suppose if you want to make it okay, work for first, okay, 15 natural numbers, let it be 50. Okay, or if you want to make it work for first 100 natural numbers, make the number value 100. That's a base case. Base case should be number equal to 100, right? So there you can make the change, right? So now let us make it back to 10. Okay, sum of first 10 natural numbers is then you are calling the sum natural function recursively within itself, and finally you are getting the result. Now I hope that you understood the concept of recursive functions, right? So recursive function is a process of dividing the problem into smaller subproblems and solving them in a sequential fashion in such a manner that every solution of every subproblem is passed as the input as the process for solution for next subproblem, and finally there should be a base case to end or to stop the process of no doing this recursive function. So this base case is the case where the problem cannot be further subdivided into smaller subproblem. So this is what recursion, and recursive function is a function that calls itself and until a condition is met. That is what called recursive function is. And what are the advantages of this recursive function comparing to looping structures using or iterating structure? So to solve this factorial of a number, or to solve sum of first 10 natural numbers or 15 natural numbers, actually you have other solution also, that is looping structures. But what is the advantage of using recursive function than using looping structures is the recursive functions are making the code look beauty, or look okay, good, or look very neat and clean, right, and very easy to understand. And second thing is, for some of the cases or most of the cases, this recursive function or method of solving a problem in a recursive fashion is okay, very time consuming, very lesser time, and its time complexity is very less, except for one or two problems. And next, the drawbacks of this is actually it will consume little more space in the memory, because for every call of this recursive function, there will be an allotment of memory space in the stack, and memory for a set of variables. One copy of variables will be created, and so that memory complexity or memory consumption is a little high when you are using recursive functions. So I hope that you understood the concept of recursive functions with these examples, and keep on practicing programming, and happy programming. Thank you.